In this lesson, we will be studying trigonometric functions of non-acute angles. In an earlier lesson, we were studying trig functions as they relate to acute angles. Now, how do we generate or how do we understand trigonometric functions of non-acute angles? To get us started, let's study reference angles. Associated with every non-quadrantal angle in standard position is an acute angle called its reference angle. So every non-quadrantal angle in standard position has a reference angle. What's a reference angle? A reference angle for an angle theta, written theta prime, so this is how you and I are going to write a reference angle, theta prime. It is the acute angle made by the terminal side of an angle theta and the x-axis. Let me insert theta right here of an angle theta. Now, pay close attention. This reference angle is made by the terminal side of your angle theta and the x-axis. Reference angles are always positive and are between 0 degrees and 90 degrees. So reference angles are positive and between 0 degrees and 90 degrees. Let me show you some pictures. I've drawn you 4 different angles. Now they're all angles in standard position and they're all non-quadrantal angles, meaning none of the terminal sides lie on any one of the axes. So these are non-quadrantal angles in standard position. Now the definition for a reference angle is the acute angle made by the terminal side of angle theta and the x-axis. Now, for an angle in quadrant 1, it's not that interesting because the terminal side and the x-axis would be this acute angle, which is exactly what theta is. So theta prime, the reference angle, is exactly the same as theta here if it's in quadrant 1. So nothing really interesting here. But in quadrant 2, the reference angle is the acute angle that is formed by the terminal side to the x-axis. So this right here would be the acute angle theta prime, the reference angle. For quadrant 3, it'll be, again, the terminal side. Now be careful, a lot of times students make a mistake and make the reference angle the terminal side to the y-axis. That's not true. It's the terminal side and the x-axis. So we're going to go from the terminal side here to the x-axis. Remember, it has to be acute, so you don't want to go to this x-axis over here, not to the positive x-axis. That would be something obtuse. So we want an acute angle, so it's the terminal side to this negative x-axis here. That's theta prime, or the reference angle. Finally, in quadrant 4, the reference angle is here from the terminal side to the x-axis. That's theta prime, or the reference angle. Okay? Now, how are you and I going to find the measure of theta prime, the measure of the reference angle? Well, for quadrant 1, it's pretty simple. Since theta and theta prime are the same in quadrant 1, theta is equal to theta prime. But in quadrant 2, notice that you can find the measure of theta prime, the reference angle, by subtracting theta from 180 degrees. If you subtract theta from 180 degrees, you'll be left with theta prime. When we go to quadrant 3, notice that in order to find theta prime, you can subtract theta from 180 degrees. If you subtract 180 degrees, the other way around, from theta, subtract this amount, watch, 180 degrees, that much, from theta, you'll be left with just this amount. So theta prime is equal to theta minus 180 degrees. Finally, if your angle is in quadrant 4, then theta prime can be found by subtracting theta from 360 degrees. So keep this handy, this information handy, as you and I go and start doing some work, and you and I are going to have to find some reference angles. So let's do that now. All right, here we go. Find the reference angle for each of these angles. Let's do 294 degrees first. Now, 294 degrees is in quadrant number 4. Because it's in quadrant 4, you and I can find theta prime, right, the reference angle, by subtracting theta from 360 degrees. In other words, we can find theta prime by subtracting 294 degrees from 360 degrees. So therefore, the reference angle for 294 degrees is 66 degrees. Just in case you're more of a visual learner, this is what's happening here. So theta that they gave us is 294 degrees in quadrant 4, and theta prime was found by subtracting 294 degrees from 360 degrees to give us 66 degrees. Cool. Let's go to part B, 883 degrees. Now, before we find the reference angle, let's first find the coterminal angle of least positive measure first, all right? So let's subtract as many rotations as we can until we get an angle of least positive measure. I believe we can subtract 2 full rotations, 2 multiples of 360 degrees. That would be 720 degrees. That's what we're going to subtract from 883 degrees in order to find the coterminal angle of least positive measure. So we have found that the angle that is of least positive measure, that's coterminal with 883 degrees, is 163 degrees. Now 163 degrees is in quadrant number 2. Now that's very important that you and I know that both 883 degrees and 163 degrees, remember these are coterminal, that means they have the same initial side and the same terminal side. They both reside in quadrant 2. For both of these angles, their terminal side is in quadrant 2. Because it's in quadrant 2, you and I will find the reference angle by subtracting theta from 180 degrees. All right, let me show that now. So theta prime, the reference angle, would be equal to 180 degrees minus 163 degrees. So theta prime is going to be equal to 17 degrees. Let's be very clear. This angle here, the first one I found, that's coterminal with 883 degrees. This is coterminal. This one is the reference angle for 163 degrees. Once again, here's a diagram just in case you would prefer to see a picture. So 883 degrees is the angle that they gave us, right? So that's what it is, which is also coterminal with 163 degrees. And the reference angle we found, theta prime, is 17 degrees. All right, this next example is extremely important, so pay close attention. Find the values of the 6 trigonometric functions of 225 degrees. All right, I've shown you an angle, the angle 225 degrees. Notice it's in quadrant number 3, okay? Now, we already proved in an earlier lesson that we can choose whichever point we want on the terminal side of this angle in order to find or generate the 6 trigonometric function values, any point we want. Now, I am going to suggest that we choose the point, let's choose the point on the terminal side that is root 2 distance, a root 2 distance from the origin. So choose the point on the terminal side such that the distance from the origin to the point is root 2 units away. Why root 2? You'll see in just a second. It's for convenience sake. But just remember that we can choose whatever point we want. I'm going to choose root 2. Okay, the point such that the distance from the origin to that point is root 2. So we're choosing r to be root 2. This distance here will be root 2. We have to find the values of x and y. Both of them are going to be negative because we're in quadrant 3 here. But we have to choose the values for x and y that such that x squared plus y squared gives us r squared. Well, that must mean x is -1 and y is -1. Because, after all, by the Pythagorean theorem, we would have x squared plus y squared, right? Must be equal to r squared. And that's true. -1 squared plus -1 squared is equal to √2 squared, right? We would have 1 plus 1 is equal to 2. 2 is 2, right? So with these values, right, choosing x and y to be -1 satisfies this identity. All right, so we chose r to be √2, right? This distance r to be √2, which means that x must be -1 and y must be -1. Now that we know what x, y, and r are, we can write down our 6 trig function values of 225 degrees. So sine of 225 degrees will be opposite over hypotenuse. So it will be y over r, so -1 over √2, which when rationalized is -√2 over 2. That means cosecant, the reciprocal of sine, of 225 degrees will be equal to -√2. Cosine of 225 degrees is the same. It'll be adjacent over hypotenuse, or x over r, which is -1 over √2, which is -√2 over 2 when rationalized, which implies that secant, which is the reciprocal of cosine, of 225 degrees is -√2. Finally, tangent of 225 degrees is defined to be y over x, or opposite over adjacent, so it will be -1 over 1, -1 over -1, excuse me, which is +1, which means cotangent, which is the reciprocal of tangent of 225 degrees, is 1 as well. Now, here is a huge point for this problem. The whole point of doing this problem is the following. Pay close attention. These function values should look awfully familiar to you. Actually, these trig function values of 225 degrees correspond in absolute value to those of its reference angle. What do you mean? Well, what is the reference angle of 225 degrees? The reference angle is made by the terminal side and the x-axis. What is this reference angle? It is 45 degrees. So theta prime is 45 degrees. And the thing is, sine, watch this, sine of 45 degrees is √2 over 2, which is basically the absolute value of -√2 over 2. We generated all 6 trig function values of 45 degrees in an earlier lesson. You should remember that cosine of 45 degrees is √2 over 2. Tangent of 45 degrees is 1. Cosecant of 45 degrees is √2. Secant of 45 degrees is √2. Cotangent of 45 degrees is 1. So all of these trig function values correspond in absolute value to those of its reference angle of 45 degrees. The signs are different for sine, cosine, secant, and cosecant, right? Because 225 degrees is a quadrant 3 angle. But these results suggest a shortcut for finding the trig function values of a non-acute angle by using the reference angle. So from now on, what we'll do, instead of finding the 6 trig function values of something like 225 degrees, what we'll do from now on is, first, we will find its reference angle. In this case, it would have been 45 degrees. And then we will find the 6 trig function values of the reference angle, which would be the absolute value of all of these answers here. And then finally, just choose the correct sign. All right, guys, these are the few steps here that we're going to use to find trig function values for any non-quadrantal angle. First of all, if the angle theta that they give us is more than 360 degrees, or if theta is negative, then we have to find a coterminal angle first, okay? And there's instructions on how to find a coterminal angle here, but you and I went through this in an earlier lesson. So if you need to, step number one is only needed if your angle is more than 360 degrees or is less than 0 degrees. Find a coterminal angle first. Then step two, find the reference angle. And we talked a little bit of how to do that a few minutes ago. Find the trig function values for the reference angle that you just found. Then, to wrap this up, determine the correct signs. Now, step four is so important. Determine the correct signs for the values you found in this step number 3 here, okay? And then this gives the values of the trig functions of angle theta. So remember what quadrant you're in, right? In order to choose the correct signs. Let's do an example now. All right, we have this one. Find the exact value of each expression below. All right, sine of negative 150 degrees. Because they gave us an angle that is negative, we have to find a coterminal angle here. Of course, we want to find the coterminal angle of least positive measure. So what we're going to do is we're going to add 360 degrees to negative 150 degrees to find the coterminal angle. Okay, after adding 360 degrees to negative 150 degrees, we get a coterminal angle of 210 degrees, which happens to be in quadrant 3. Now, in quadrant 3, sine is negative. Remember, all students take calculus? In quadrant 3, sine is negative. So I already know my final answer will be negative. What I want to do now is find the reference angle. That's step number 2. Find the reference angle. Let me also move the screen up because I'm running out of space. Now the reference angle, because we're in quadrant 3, the reference angle will be found by subtracting 180 degrees from 210. That would give us 30 degrees. So now what I can do, now we're at step number 3 here, folks, find the trig function values of the reference angle. So we're going to find sine of 30 degrees. Which is equal to 1/2. Now we're not done. Let's wrap this up here. Okay, all we have to do is step number 4, which is determine the correct signs. I'm going to move the screen up again here. All right, so here it is. Here's our final statement. All right, you guys, because we were in quadrant 3 here, that's the angle that they gave us, quadrant 3, we know that sine of negative 150 degrees, right, that's the original value of theta here, will be equal to, watch this, the opposite of sine of 30 degrees, which is negative 1/2. Remember, if this minus sign were not there, then we would just have sine of 30 degrees, which is positive 1/2, which is not the answer. The correct answer is negative 1/2 because we're in quadrant 3. So I said sine of negative 150 degrees is equal to the opposite of sine of 30 degrees. So the final answer is negative 1/2. Let's go to the next one. Cotangent of 780 degrees. Because this angle is more than 360 degrees, we're going to have to subtract, I think, 2 rotations. We're going to have to subtract 360 degrees twice to find the coterminal angle. Okay, guys, I subtracted 360 degrees twice, and that would give me 60 degrees as the coterminal angle. Now, guys, the coterminal angle is in quadrant 1. Everything is positive in quadrant 1. Therefore, cotangent of 780 degrees, I know right now it will be a positive value. Furthermore, in quadrant 1, the reference angle is exactly equal to theta. So theta prime is equal to theta. So in other words, 60 degrees, the reference angle for 60 degrees is 60 degrees itself. So the whole reference angle step is kind of not needed in this example because the reference angle is exactly the same as the angle that's under consideration, which is 60 degrees. Okay, so let's go ahead and find the trig function value, cotangent of 60 degrees. Now 60 degrees is one of our special angles, and we found in an earlier lesson that cotangent of 60 degrees is root 3 over 3. Now, because both 780 degrees and 60 degrees, remember they're coterminal, because they're both in quadrant 1, that means they have the same sign, which is positive, because everything's positive in quadrant 1. So my final answer is going to look something like this. All right, cotangent of 780 degrees is going to be the exact same thing as cotangent of 60 degrees, which is root 3 over 3. Now notice that I do not have that negative sign right here like I did in the previous problem, and that's because this angle they gave us was in quadrant 3, whereas this angle that they gave us is in quadrant 1. You just got to be careful with the signs. All right, next example, evaluate, which means find the value of sine squared of 45 degrees plus 3 times cosine squared of 135 degrees minus 2 times tangent of 225 degrees. We want to do all of this without a calculator. Now, some of this work we have done already. Like, for example, we already found out that sine of 45 degrees is root 2 over 2. We know that already, root 2 over 2. For 135 degrees and for 225 degrees, we want to use their reference angles. Now, the reference angles can be found for 135 degrees and 225 degrees to be 45 degrees. Now, we have to be careful here because 135 degrees is in quadrant 2 and cosine is negative in quadrant 2. 225 degrees is in quadrant 3 and tangent is positive in quadrant 3. So I'm plugging in root 2 over 2 for sine of 45 degrees, but don't forget you have to square it, so I'm squaring it, plus 3 times cosine of 45 degrees, because that's the reference angle for 135 degrees. But I have a negative sign right here because cosine of 135 degrees is not the same as cosine of 45 degrees. It's actually going to be the opposite in sign, because 135 degrees is quadrant 2, and cosine's negative there, so that's the reason for the negative. I know that once we square it, see me squaring it here, it'll become positive, but at this step I should see a negative. Minus 2 times tangent of 45 degrees. Instead of 225 degrees, I'm using the reference angle, 45 degrees. Now, I don't have a negative here to worry about because in quadrant 3, tangent is positive. All right, let's keep working. Okay, I squared root 2 over 2. And then cosine of 45 degrees is root 2 over 2. I brought down the negative, and we are squaring this value. Tangent of 45 degrees is 1. All right, I squared negative root 2 over 2. Now it is a positive value at this step, and it is 2/4. So now it's just arithmetic. Let me move this screen up a little bit here. So now we have 2/4, which is 1/2. And if you want to simplify that right now, you can. You don't have to yet, as long as your final answer is simplified. But I'll go ahead and simplify it now if you'd like. 2/4 is 1/2. Plus, now this 2/4 is also 1/2. When you multiply it by 3, you get 3/2, right? Minus 2. 1/2 plus 3/2 is 4/2. And then minus 2. Let me move this up a little bit further here. 4/2 is 2. Minus 2, 0. 0, this whole expression turns out to be equal to 0. That was a lot of fun. All right, evaluate each function below by first expressing it in terms of a function of an angle between 0 and 360 degrees. All right, so the first thing you're going to want to do is take each of these angles, 585 degrees, and negative 930 degrees, and get a coterminal angle of least positive measure is basically what they're saying. And then you can evaluate each of these. I think this is a perfect example for you to pause this lesson right here. Pause the video, please, and try both of these on your own. Okay, I'll give you time to do that. Go ahead and pause the video, please. All right, how'd you do? Let's go through our work together. So the first thing I did for sine of 585 degrees is found a coterminal angle by subtracting 360 degrees. That coterminal angle turned out to be 225 degrees, which is in quadrant 3. That's very important that you understand that it's in quadrant 3. The reference angle for 225 degrees is 45 degrees. I have the negative sign right here. Make sure you have that as well. I have the negative sign right here because in quadrant 3, sine is negative. So there's the negative, and sine of 45 degrees is root 2 over 2. I'm hoping that you're getting really familiar with the function values of your special angles. So sine of 45 degrees, you don't have to punch that into the calculator. You don't have to look for it in your notes. I'm hoping that you now know it's root 2 over 2 really quickly. For cotangent of negative 930 degrees, I first found a coterminal angle for negative 930 degrees by adding 3 rotations. So 360 degrees times 3, which is 1080 degrees. And when I add that to negative 930 degrees, I get 150 degrees. This is coterminal. Now, 150 degrees is in quadrant 2. That's important because cotangent is negative in quadrant 2. That's the reason I have a negative sign here. Make sure you have it as well. The reference angle for 150 degrees is 30 degrees. And we know cotangent of 30 degrees is root 3. So our final answer is negative root 3. Good job. Okay, guys, this is going to be our last example for this lesson. Find all values of theta. Find all values of theta if theta is in the interval 0 degrees to 360 degrees and sine of theta is negative root 3 over 2. First of all, let's be very, very, very clear that they are looking for values of theta. In other words, your final answers should not be real numbers, right? Like root 2 over 2 and root 3 over 3 and things like that. Those are real number values. No, our final answers should be angle measures, degree measure. They're looking for values of theta. Okay, that's very important. In the previous example, they were looking for like sine of 585 degrees and cotangent of negative 930 degrees. And your final answers were negative root 2 over 2 and negative root 3. Your final answers were actually real numbers. In this example, they're not asking you for sine of theta. No, they're asking you for theta. They're not asking you for cotangent of theta. They're asking you for what is theta itself. So what is the angle measure? All right, so I hope that's clear. Let's start with this statement here, that sine of theta is a negative value. First of all, sine of theta is negative. This means that theta must be an angle in either quadrant 3 or 4. Remember, all students take calculus. Sine is negative in quadrant 3 or 4. So this theta, this angle right here that you and I need to find, must be in either quadrant 3 or quadrant 4. Furthermore, the absolute value of sine of theta, which would be the absolute value of negative root 3 over 2, is positive root 3 over 2. Now, you and I know that must imply that theta prime, the reference angle, is 60 degrees. Because you and I already know that sine of 60 degrees is root 3 over 2. So theta prime must be 60 degrees. Now, let's go to quadrants 3 and 4. So in quadrant 3, the reference angle is 60 degrees. That must mean that our actual angle, theta, is all of this amount here, which would be 180 degrees plus 60. What is that? That's 240 degrees. So there's one answer right here, folks. 240 degrees is the answer if theta happens to be in quadrant 3. Now let's go to quadrant 4. So here we are in quadrant 4. The reference angle is 60 degrees. That implies that theta would be this amount right there. Basically, 360 degrees, right? 360 degrees minus 60 degrees, or 60 degrees shy of 360 degrees. So 360 degrees minus 60 degrees would give me 300 degrees. So all of this is theta. So 300 degrees is our other answer, our second answer, and that's if theta is in quadrant 4. All right, everybody? Wow, that was a really interesting problem. All right, it was a lot of fun. I hope you had fun too. I'll catch you later.